Um, cool. So let's give it a try. So this binary search is kind of a mandatory when you talk about searching inside an array. And when you are talking about searching, it's finding an index or finding an element or a value. I'm not when I'm saying that. I'm saying that in the context of an interview. When you are doing it for yourself, go for a naive method and boom, voila, and it works and you're happy. But during an interview, it's like the basic, it's to do a binary search. So it works under some condition, it doesn't work everywhere. It's kind of pretty advanced, binary search, but it's pretty easy to understand the logic. So I think everybody can follow, just like follow what I'm saying, especially at the beginning. It's important, otherwise you will get lost. My part, so I will tackle prime at the beginning, and then we will code it. Um, so everybody can see my screen. Yeah, cool. So what are we doing? So binary search only works with a sorted array. So what is it? We have this array. I will go for a small one, because it's easier to deal with. And we are looking for an element like 7. Search for an array. So if we are looking for 7, the standard method is that we are at index 0. 1 is not 7, 3 is not 7, 4 is not 7, 7 is 7. So we got it, we return the index, we are happy, everybody celebrate, cool. But since we are in a sorted array, we can go faster. And that way to go faster is binary search. How does it work? You take the middle of the array and you start from there. Since it's sorted, on the left of that value, it's less, and on the right, it's more. So if we just need to do that comparison here, 4, if 4 is less than 7, it means what we are looking for is on the right. And if it's more, it means that what we are looking for is on the left. So in that case, it's on the right. So after we do the same logic, we divide that size, from the middle to the end by 2. So we are in the middle of the subarray, and we compare and say if it's that value or not. And let's add another one in order to make it a little harder. 6, actually 5. It doesn't work well in my example, but it's for you to see the logic here. 5, no, it's bigger, so we do a jump, to the middle of the next one. The middle will be 7, and in only 3 comparison, we found it. But if we were looking for like one by one, we would have done like 1, 2, 3, 4, 5, 6. So it's kind of dividing into 2 parts, and each time, jumping. This thing has a big O of log n. The more elements we have in the array, kind of it's not a linear conversion. It's not like if we are looking for the naive one, it's n. If we have n elements in the array, we have to do worst case n comparison. But in this one, we tend to go like to do less comparison. Question?
Do we know the size of array? Like,
So yes, yes, we need to know the size of the array. Especially in C, because we don't know the size of the array, otherwise we can't iterate through it. So yes.
why I ask because in C we have a string it is a function which counts every number through the array. So the algorithm will go through every number, and why if you don't know the size, for example, we have to go through each number, and why just don't look for this number?
Yep. If we don't know the size and it's not sorted, but we can't do research.
Okay.
We need to have those two elements. And thanks, yeah. Cool. Cool. That's good. So what we're gonna do is first part. No, I always like to write what I need to do because otherwise I forget. Part one is we init an array with values. I think we'll do something similar than my range, quest for exercise 0, with a min max. Then we do my binary search. We will do my naive search and my binary search. But maybe we do first a print array. Okay. Cool. So let's do struct as array. I'm doing a struct in order to have the size of the array with me all the time, because otherwise I would have to send it as a parameter, and now I think only objects, so I use struct int array. So we have a pointer on an integer. We create this struct this array. I will do type def. So I can use it like that. So I have my array equal init array, and we send like a min. So let's say 3 and then cool. So let's go to that function that we return. I was chatting with one of you. When I'm coding a function, it's always about input and output. So here, I started by what will be the output. So it's an array. It's my struct that I would have allocated because I'm sending returning a pointer. And the two input I got, it's in min and int max. So from that, now I need to do the middle. Return result. Cool. So I need to malloc it. Malloc size of int r. Cool. And size will be max minus min. Will be the number of elements. Then we need to malloc again for the number of elements. So it will be size of int by size. So we're allocating the n cell and size cell of int. Size cool. Let's fill our array. Y min inferior to max. Then 1 and result array. Okay, let's create a print function in order to debug it in case of. So print will return void because it will just print. Print array, and the parameters are all array. It will be very similar to that. Yeah. x, but here it's index inferior to the number of elements inside the array, so size. Then we only increment this one. Let's print a little. So if index it's not the first one, so it's superior to 0, we'll add that nice little and then we print the elements. D, so it's integer, so D is now, and last one. It's missing something here. Oh, oh, let's check it out. Hope it works. All right. By where are we? Okay. Result and declare, yeah, because we name it array. So we have values from 3 to 9. 3 is included, 9 is not. Makes sense here. Okay, no problem with that. Cool, it works. So let's do a naive search. First, how does it work? I will return the index. So we need the array and the value that we are looking for. So simple, we need to iterate through each element of the array in order to get what we want. So same thing, actually, I should copy paste it to be faster. And the loop, never forget, and if current value is equal to the one that we are looking for, it's written as the index, the value that we have where we are. And if we haven't found it, it means that we have exited the loop and we are outside. So let's check it. Search naive. \n, and we call the function. And we are looking which number? 7 again? Cool. So we found it, it's at 4, so 0, 0, 1, 2, 3, 4. Cool, seems to work. If, yeah, I would, usually I test like, even when it doesn't work, you know, to make sure. Cool, so let's now do my binary search. So same prototype. So what do we want? So we are here. What we need is to kind of the delimitation of the array. And there are multiple implementation of it. One of them is recursive, and you can. So what we want is to divide the array into sub-array, and only looking in that sub-array if it is inside it or not. So to do that, we need to kind of know what are the limits of the array. Here, what I'm gonna do is I will use 2 indexes, actually 3. One at the beginning of the array, one at the end. So let's put a dollar and yes. And so I will check the middle one. And let's say the value is on the left. So what I'm gonna do is I will move the end value to the left, to the middle one. So now I have a new array, which is like that. New, no, it's which is from 1 to 5, and it will give me a size, and I will divide the size by 2 in order to get the middle. So this is the algorithm to do on the left, and it's pretty similar on the right, but instead of moving at the end, I will move the beginning, and beginning will be now here, and it's not moving, and middle will be the size divided by 2. So let's do it. So we need a beginning index initialized at 0. We need the end index initialized at the size -1. Array size -1 and y beginning index inferior to end index. We will do the loop. So we have a middle index, which is the size. So the end minus the beginning divided by 2. And if the array the index is equal to the value that we found what we are looking for, so we will return this index. I will do the end. If we don't find anything, it's -1. So this is simple case. Harder case is we haven't found it. So now it's need to compare, and we need to think a little. So I'll just copy paste it, and my last case is else. Maybe I will do the other way. So I will do if one case, else if the other case, and else I means that we found it. We don't need to do this one and else. Cool. So if the value inside the array is bigger than the value that we are looking for, it means that we need to search on the right. No, we bigger, so we need to search on the left. So I will, yeah, maybe I will add a debug here after. In order to make sure that I'm looking on the left. And the reverse, let's do the same. So if the value is less than, the current value inside the array is less than the value that we are looking for, it's remove right. You go on the right side. Cool. So what does it mean? It means if we go to the right side, it means that beginning equal middle. And if we move to the left, it means that end is equal middle. So let's keep the procedural level. Okay, so I think that's it. Middle, let's make sure I'm not doing a mistake here. I think I'm doing a mistake here, because middle index is not incorporating here. Yeah. So this is the size, and we need to have the padding at the beginning with the beginning index. And let's make sure that the divide by 2 is applied on this. Yeah, let me show you what I did here. So we are looking on the right side, and so we have the size. The size is 9 minus 5, 4. And if we go on middle index is equal to 4 divided by 2, we have middle index 2, but the problem is that 2 is here. And what we want is from the base, so from beginning index, and beginning index is 4, so what we want is 6, 4 plus 2. So this is why I put that back. Let's compare. doesn't compile. Why? And I search because I didn't name well the function. Yeah. Okay. It's short. One shot. So let's use A to search for a value. I will increase the size of the array and int search value is equal to auto ID1, and I will send it as parameter here. Because before it was hard coded, now I can send it as parameter. Or execute. Oh, execute. 7. So it's at fourth position. Cool. Let's another one. 16. Cool. Let's look for someone that doesn't exist. Ah, we have an infinity loop here. Oh, let's. I guess it's because this condition is not stopping. Debug it quickly. Index and index. And we're looking for 100. Yep. Here, I want maybe to understand. So there is no difference between those two. There is one. We want. I need to think a little more about the condition. Same thing, it's still looping. Why? This should work now. If beginning index it's 95 plus 1, 96, and higher. I found it. So what is interesting, I will stop here. I don't want to spend too much time on this condition. I feel it's not good. It's not working in every case, but it's good enough for now. What is interesting is how many iterations we've done in order to see that it doesn't, that it's not part of the array. We have done 7 iterations here, and I'm not printing them, but let's print them. And in the naive search, we've done way more comparison. So in comparison, if you compare the two algorithms, this one is way more optimal than this one, and like way more optimal. Questions? Cool. If you want the code, send me a message and I can give you the code. What is binary search? When you are facing an interview, they are used all the time. It can be, like, oh, I'm rotating an array, and how much rotation has been done. Bam, you need to do a binary search with kind of in order to find where that thing has been changed. How to each time you have to search for something, ask yourself, is the array sorted or not? And most of the time, people are looking for you to sort it, then to do the binary search. Naive, it's not what they are looking for because it's to brute force. It's not, computer science enough.
What what is the point of binary search? Like, when do we actually use it? Do we use it like some kind of like in database or something like that? Or is it just there to make complicating things?
So it's a good question. In your day, so let me tell you a story. Saturday, I wanted to do live. So this today was pretty straightforward. I haven't done any mistake. But Saturday, when someone asked me to code it, I made a lot of mistakes. It executed multiple times, etc. What does that mean? Binary search is part of the exercise that I've done for training. Like, hey, let's do a binary search, and I'm coding it like, and in 2 minutes I have it down. But when you ask me today, code, code it, but I make a lot of mistakes and I forget because I'm not using it at all every day. But this is where there is like that kind of gap between technical interview and your day-to-day life as a software engineer. But that you won't use it. Like, to be honest, last time I used it, it was during an interview. So when someone asked me today, I was like, today Saturday, I was like, okay, full challenge. I think I will be a mistake, because you forget, you don't use it. But during interviews, I would say like maybe 1/3 of them, maybe 25% of them, you use it. Because when you are talking about array and you need to find something in it, for sure it's binary search. And even if you are not using it, you need to mention it. Like, oh, this array is not sorted, so I can't use a binary search. Should I sort it? And you need to mention it. And that's really, it's exactly like another point. It's printing tree. Never you print tree. Like. In your day-to-day, you're coding. You're not like, oh, I have a binary tree and I want to print it, in a pre, post, middle order, all the different way. You don't care. Like, I want to print my tree in that order because, but can you do it in the post, reverse, with the eyes closed? No, I mean, you don't care. And those kind of basic things are mandatory. So that's why I use them as drill, like, let's code it, and bam. So all the sort, same thing. You won't use any sort. You call the function sort. But you need to, there is no secret here. Bad interviewers will ask you those exercises because it's what they learn during their expensive years of college, and they want to show like, oh yeah, oh, it's so important to know those sorts, like quick sort, merge sort, insert sort, blah blah blah. To be honest, they are not. This is not hard at all. It's just practice.
Can you see HubSpot?
Yes.
Yes. I can. Are you presenting something?
I am. I'm going to show you
Okay.
why I like binary sorts and why I like it when you guys can sort things.
Hmm.
This is like the real world here. So if you had to go out and rebuild HubSpot, I've got a big database here. Okay, and if you look at this is something called close date. So it's the date that something happens. And I want to know, in this case, it's between the 1st of October and the end of December. But I can also say is known or is unknown. That's fairly binary, right? Like, I know it, there is a value, or there is no value. And you can see all sorts of different filters in here. And these look really nice filters, It's a nice interface. However, if I actually want to make something happen when I click these buttons, that's where, like, you guys, that what you're learning is applicable to actually making this functionality real. But we're going to go a step further. So if I want these deals in alphabetical order, I'm just going to click. Again, magic, things happen in my software, but in the real world, like, somebody is clearly a software engineer, has gone away and actually coded it so that when I click that button, look, it's magically sorted by alphabetical.
Or I could go over here to unit price items, do the same thing, and kind of click. Oh, look, now it's sorted by number. And there's, again, deal type, something different. So this is a real world application of a lot of the, I think, individual things that you guys are probably learning and wonder, like, why would I actually use this? Well, if you were a software engineer at HubSpot, you'd read that. There you go. So any kind of database where there's numbers and things to be sorted and reported on. Somebody has built this functionality behind it.
Okay. Yeah, because I'm like, in my project with Yana, we are doing this I created this project database that, it just, when you click on the create button, it would just go to this new page and then you just, create a new project and stuff. And then it will add that project into the database. But then I don't know how to like have specific project for specific user because all of my project appear to all the user at the moment. So I'm trying to find a way how to like connect the database and then like learn how to like the best way to like sort it the database in general. So that's interesting. I wanted to do it yesterday, but I got an eye strain, so just but yeah, it's just something that I was just thinking, the database, like sorting and stuff. Like the more user, like the more projects, it will get, I think it will get, you would probably have to use some kind of like sorting methods, I suppose, to make it go faster instead of going like one by one.
Here, what you, yes, so database, they are already implementing those sorts, but there are more and more databases. Before it was simple. You were using either you were a company, you were using Oracle, or you were an individual like us, you were using MySQL. But now, you have SQL versus NoSQL, and in NoSQL, you have like tons of them. In SQL, you have multiple, and you also have another one, which is key value database. So the real question in that jungle is how to choose them. And in order to choose them well, because I'm your manager, and I've done some coding, some HTML and CSS, so I feel myself like an expert. But and I want you to explain to me which database we are going to use, for this project. And you have to choose. And in order to choose well, you need to look at how they are coded, where they are good, where they are not good, etc. And knowing how, maybe you don't know how to code binary search now, on the spot, but you've coded it before, so you remember kind of the logic. And if this one is good, there is a binary search, or they store string as integer, which is also faster. All those elements will make you decide, will make you do the right decision.
Okay. Good advice. I will have that done.
And to answer your question,
go ahead.
You need to do jointure, because so you have a project with user, so you need to find for that user the project for him, for her, for them. So you need to kind of do association. I'm giving you keywords here to.
Okay, so you use join. Do you have to use any like ID like for specific user with the project? Or like this projects will have like an ID that's similar to the user ID so that they can connect together.
Yeah,
somehow.
but it needs to be a little more, than similar. It needs to be actually the ID, and it's called association table. You have a project, a user, and in the middle you have another table which contain for each entry, a row with user ID and project ID.
Oh, okay. Okay, I mean, okay.
That's a big deal here because creating, a WordPress website, everybody can do it, but solving the problem that you are solving right now, it's your day to day. I can do them like I can close my eyes and do them. If you ask me to code that, I can, but if you ask me to code the binary search, I can't.
So there should be a table in the middle that's like connect the user and the project.
Association table, that's the name.
Okay. Okay. Thank you.
Cool. Alright, guys. I think that's everything. I'm excited to see Basecamp. Okay, and I think with that, we will let you guys go code, maybe have an afternoon snack or some lunch, and then we will see you guys at 4 p.m. Pacific time. Okay, all right, guys. Good to see you, and we'll see you later. Bye.